Hello students, today we'll be doing the topic of preparation of carboxylic acids. Okay, so this is the second video from this topic, and this topic is from the chapter aldehyde ketones and carboxylic acids. Okay, so I'll start sharing the screen. So preparation of carboxylic acids. Now carboxylic acids can be prepared by different methods. The first one that we'll be discussing is from the primary alcohols. Okay, this we have done in the chapter of alcohols also, alcohols, phenols and ethers. So in the topic of chemical properties of alcohols, we have done it. So alcohols can be converted into carboxylic acid by using any of the following reducing agents, which are these: KMnO4 in the alkaline medium, KMnO4 in the acidic medium, potassium dichromate in the acidic medium, and chromium trioxide in the acidic medium. This is also known as a Jones reagent. This is called Jones reagent. So all of them, if you have an alkaline medium, you have to further acidify it to form carboxylic acids. Otherwise, in the alkaline medium, you get the carboxylate ion. Okay, so which upon acidification gives you the carboxylic acid. So these are the various ways by which primary alcohols can be converted into carboxylic acids. So if I give you some examples, if I take, let's say, propane 1-ol. So this, when treated with KMnO4 in an alkaline medium, will give you what? 3 carbon alcohol will give you 3 carbon carboxylic acid, but it's salt. First you'll get the salt of this acid, that is the carboxylate ion, okay, or propanoate ion. This upon acidification will give you the carboxylic acid. Okay, same way, let's say I take this one. This is another primary alcohol. When you treat it with Jones reagent, okay, chromic oxide in the acidic medium. So again, same number of carbon atoms, so you should ensure that COOH. Since the medium is acidic, you'll directly get carboxylic acid. So next is, we can also prepare it from aldehydes. This again we had done during the properties of aldehydes, that is the oxidation reaction of aldehydes. So aldehydes, when treated with mild oxidizing agents, okay, will give you carboxylate ion, which upon acidification will give you carboxylic acid. So what is this? Which oxidizing agent? It is Tollens reagent. Okay, you use it in the silver mirror test. Similarly, this one, copper ions in the alkaline medium. What is this? This is your failing solution. Now we simply call it failing. Okay. So this again will give you carboxylate ion, which upon acidification will give you carboxylic acid. Another reaction that we had done was the iodoform reaction. Okay. This is your iodoform reaction. Iodoform test also. When methyl ketones are treated with sodium hypoiodide or NaOH in presence of I2, and you heat them, okay, you get iodoform, that is yellow precipitate, and the rest of the molecule is converted into carboxylate ion, sodium salt of carboxylic acid, which upon acidification will give you again carboxylic acid. But this carboxylic acid will have one less carbon atom from the starting material. Okay, that is descending the series. Okay. So next is from alkyl benzene. Okay, alkyl benzenes are used to prepare aromatic carboxylic acids. Aromatic carboxylic acids. Okay, so You take any alkyl benzene, for example, in this I'm taking methyl benzene or toluene. Common name of this is toluene, okay, or methyl benzene. So this again, when you treat it with any oxidizing agent, KMnO4 in the acidic medium or KMnO4 in the alkaline medium or potassium dichromate, all this will give you carboxylic acid. Okay, if it is an alkaline medium, you have to acidify it. Okay, this can also be prepared if you have a longer side chain. Okay, instead of methyl group, you might have a propyl group. Okay, primary alkyl group, or you might have a secondary alkyl group. This also upon oxidation will give you carboxylic acid. Rest of the carbon atoms will be removed. So you're left with carboxylic acid. Only thing is that if you have a tertiary alkyl group attached to the ring, this will not give you the carboxylic acid upon oxidation. Okay, so we can do it with either any of the primary or secondary alkyl group. In fact, if you have a ketonic group also over here, so this also upon oxidation will give you carboxylic acid. Okay, so next method is, I think it is the third method, from nitriles and amides. Nitriles upon hydrolysis will first give you amides. So this is nitrile. When you hydrolyze it, alkaline or acidic medium, it will give you amide. Amides upon further hydrolysis and heating will give you carboxylic acid molecule with the release of ammonia. Remember, if you use the alkaline medium, you first form the carboxylate ion. Okay, so this is how the reaction proceeds. So if I take any, let's say this one, so H positive H2O will give you the corresponding amide, CONH2. Okay, this upon further hydrolysis and heating will give you the carboxylic acid. Two carbons, same number of carbons, carboxylic acid. Same way you can also prepare aromatic carboxylic acid. Same method. You can also write it directly. Heat. So this will also give you the benzoic acid or aromatic carboxylic acid. Next method is we can prepare it by using Grignard's reagent. That is, we treat Grignard's reagent with carbon dioxide. Okay. Now in this case, again, you'll have an addition reaction. In Grignard reagent, the alkyl group carries a negative charge. So this will attack this carbon, okay, which has a partial positive charge because of the presence of two oxygens on either side. And MgX will go to oxygen. So you get an addition product, which upon hydrolysis will give you the carboxylic acid. Okay. Now, if you see it from the beginning, the carboxylic acid that you get over here has one more carbon atom as compared to the starting Grignard's reagent. Okay, alkyl group in the Grignard's reagent. So this reaction is used for ascending the series. Okay, it is used for ascending the series. For example, suppose I have to convert, let's say, if I have to convert ethyl fluoride to propanoic acid. So how will I proceed? Okay, so this has only two carbons and this will contain three carbons. So this is, I can first treat it with magnesium in dry ether to convert it into Grignard's reagent. MgCl. Okay, so this upon when you treat it with carbon dioxide, number one, you treat it with carbon dioxide. Number two, you carry out hydrolysis. Okay, so what do you get? You get this three carbon carboxylic acid. Okay, so this is what we say ascending the series. In fact, With the iodoform reaction, we had this descending of the series. One carbon less, that is called descending the series. Okay, homologous series. So next method is from acid derivatives. All the acid derivatives upon acidic, alkaline hydrolysis or hydrolysis with water will always give you carboxylic acids. So which are the acid derivatives? For example, the first one is acyl chloride. Acyl chloride, when you treat it with water, will give you carboxylic acid, same number of carbon atoms. Or when you carry out the alkaline hydrolysis, it will be a faster reaction. Okay, so you get first carboxylate, which upon acidic hydrolysis will give you carboxylic acid. Okay, similarly, acid anhydride, when you treat it with water, will give you two molecules of carboxylic acids. At the same time, esters, this reactions you have done before also. Esters, when hydrolyzed in the acidic medium, it is a reversible reaction. What do you get? Carboxylic acid and the alcohol. This R dash, this alkyl group which is attached to oxygen will be converted into alcohol. When you when you do the alkaline hydrolysis, the reaction is also called saponification reaction. Again, what do you get? Sodium carboxylate, which upon acidic hydrolysis will give you carboxylic acid. Okay. So if I take an example, let's say I take CH3COCl. Okay. So this can be converted into acetic acid, 2 carbon carboxylic acid when you treat it with water. Okay. At the same time, what is this called? I'll tell you the name also. Ethanoyl chloride. Common name of this compound is acetyl chloride. Many times you'll be using it in your conversion. Acetyl chloride. Similarly, if you take an anhydride, acetic anhydride, okay, or ethanoyl anhydride, okay, ethanoic anhydride or acetic anhydride. This again upon when you treat it with water will give you carboxylic acid. Okay. Third one is the ester. So let's take an ester. Okay. So alkaline hydrolysis, alkaline or saponification reaction, number one. Number two, followed by acidification. Okay. So what will be removed from here? Minus CH3OH. This will be removed and you'll get acetic acid. Okay. So this is how all these derivatives of carboxylic acids can be converted into uh, carboxylic acid itself. Okay. So now I take up the question, in-text question of NCERT. That is question number 12.7. How will you convert all these compounds into carboxylic acid? Okay. So again, first one, you have an alkyl side chain, KMNO4. Let's take alkaline medium, followed by H3O positive. Okay, you get the carboxylic acid. Now this is what? Acetophenone. This molecule is acetophenone. So this can also be converted into carboxylic acid by the same process. Okay. It can also be converted into carboxylic acid by another method. Can you guess? By another method, that is when you treat it with, I'll write it on the other side. By treating it with sodium hypoiodide. Sodium hypoiodide, I over here. So I just, this has to be removed. So NaOI. So iodoform will be removed and rest of the molecule will be converted into carboxylate ion, which upon acid hydrolysis will again give you carboxylic acid. Okay? So benzoic acid. You have to convert all of them to benzoic acid. Okay, what about this one? This is bromobenzene when treated with magnesium will give you what? Grignard's reagent. So we had just done this reaction when you treated with carbon dioxide followed by hydrolysis will give you carboxylic acid over here. This again is simple. I think it is the same one. Okay, this was actually ethyl benzene. If I remember, this was ethyl benzene. So again, oxidizing agent, strong oxidizing agent, this bond will break, okay, and it will give you carboxylic acid. So these are the various methods by which we can prepare carboxylic acids. So there's a brief chart over here which gives a summary of all these methods. Is this clear? So with that, we finish with this topic of preparation of carboxylic acids by various methods. Okay. Thank you and bye all of you. Stay safe.